Alright, the second part of this chapter, simple machine. Okay, lever. What is lever? So lever is a simple machine. Okay, it's a rod that rotates at a fixed point called fulcrum. Okay, so any rod that rotates at a point, that point is called as a fulcrum, is called as a lever, and lever is a simple machine. Okay, so we have already done mechanical advantage. So mechanical advantage is load upon effort. So whatever the load you apply, and the force that you apply is called effort, and force that the machine applies after applying that force is called as load, and the ratio is called as mechanical advantage. All right. So lever, remember one thing, it's simply a rod that rotates at a fixed point called a fulcrum. Right. Now, what is the principle of a lever? On what principle does it works? So let us understand few terms which I've already gone through. So lever is a rod. Okay, it rotates on a fixed point called a fulcrum. Now, when you apply a force, that force is called as an effort on a lever, and whatever the lever does the work is called as a load. Okay. Now, the distance between where you are applying the force, that is your effort, till the fulcrum is called as effort arm, and the distance from load till the fulcrum is called as load arm. Okay, and the principle of lever is simply load into load arm is equal to effort into effort arm. Okay, so this is the principle of lever. Load into load arm is equal to effort into effort arm. Now we'll rearrange this equation. So we'll take load and effort at one side. So load, when the effort will come this side, it will be upon. So load upon effort will be equal to load arm, effort arm upon load arm. Okay, but we know that load upon effort is nothing but mechanical advantage. So mechanical advantage is equal to effort arm upon load arm. Okay, so mechanical advantage can be found out by measuring the length of effort arm, the distance from where the force has been applied till the fulcrum, and upon the distance of force what the machine is applying till the fulcrum. Okay, that will give us mechanical advantage. So this is the principle of lever. Now other thing, mechanical advantage of a lever is the ratio of the effort arm to the load arm. So it is a ratio, hence it has no units. Okay, mechanical advantage is also called as force ratio, and since it's a ratio, it has no units. All right, based on this, there are three scenarios. Okay, mechanical advantage can be equal to 1. Okay, it can be greater than 1, or it can be less than 1. Now, if it is equal to 1, that means that effort arm and load arm are equal. If it is greater than 1, that means effort arm is greater than load arm, and if it is less than 1, then effort arm is less than load arm. And why so? Because mechanical advantage we just now did, it's effort arm upon load arm. So if effort arm, so in the first scenario over here, say for example effort arm is 10 and load arm is 10, in that case 10 get cancelled, it becomes 1. So mechanical advantage is equal to 1. So mechanical advantage becomes 1. In this case it just balances, or mechanical advantage, okay, we'll do it later. So mechanical advantage becomes 1. Over here if you see, this effort arm is more. So over here, say for example this effort arm is 15 and this load arm is 5. So again when we substitute these values in this, okay, so here effort arm would be 15 upon load arm 5. 5 ones are 5 threes are. So mechanical advantage will become 3, which is greater than 1. Okay, all right, so mechanical advantage will be greater than 1. In such scenario we say it's a force multiplier, it multiplies the force. Okay, if effort arm, okay, it is smaller, say for example here it is 5 and here this load arm is 15, in that case it will become 5 and this will be 15. 5 ones are 5 threes are, so it will be 1 by 3. 1 by 3, it will be 0.0, so 3 threes are 9 1, so 3 3, so it will come to 0.33. All right, so it is less than 1. Okay, so if it is less than 1, what do we say? It's a speed multiplier. Okay, so these are the three scenarios. It is just based on the length of the arm. Okay, so if effort arm is more, it is greater than 1. If it is less, the mechanical advantage is less than 1. Okay, if mechanical advantage is greater than 1, what happens? So if you apply a load, so the effort arm is greater, load arm is smaller. In that case, mechanical advantage is greater than 1. And in that case, if the load arm is smaller than the effort arm, the mechanical advantage becomes greater than 1. And this time it is called as a force multiplier. What it does, it multiplies the force that you apply. So anytime when a mechanical advantage of a machine, it is greater than 1, it is multiplying the force that you are applying over here. So it acts as a force multiplier. Okay. For example, over here, the effort arm is greater, okay, and the load arm is very small, okay, and this is the fulcrum. Okay. So here it becomes crowbar. It acts as a force multiplier. The other, okay, mechanical advantage, if it is less than 1, what happens if it is less than 1? Why we use a machine where a mechanical advantage would be less than 1? In this scenario, it acts as a speed multiplier. Okay, so if a load arm is greater than the effort arm, the mechanical advantage is less than 1. And if mechanical advantage of a machine is less than 1, machine acts as a speed multiplier. The example would be a scissor. So if you see, this is the fulcrum over here. This distance, okay, it is less than this distance over here, right? So in this case, this machine, it acts as a speed multiplier. You are traveling a force, you are applying over here, and you are traveling a very small distance, okay, whereas when scissor, it opens and it closes, it travels a greater distance. So even with a less distance that you travel, it travels a greater distance, or it cuts with a greater speed. All right, so it is a speed multiplier. When a mechanical advantage is equal to 1, okay, in that case, now why will you use a machine where it is giving us the same output? Okay, so here it helps in changing the direction of the machine. Okay, so seesaw is an example, but a better example would be a pulley. So if you see, if you have to draw water, okay, from a well, in that case you have to, by the rope, okay, so you have to lift it or you have to pull it up. Okay, now you are doing a work against the gravity over here. Okay, but if you use a pulley, in that case, what happens is, pulley, you have to do the same work, but what it does, it makes your work convenient. Now earlier you are lifting it upwards against the gravity, now you are pulling it down. You can apply your body weight, as well as you are doing a work towards the gravity. All right, so what it has done, what pulley has done, it has simply changed the direction, okay, in direction where you have to apply the force. So it acts as a, it makes a work convenient. Okay, so that is one of the work of a machine. All right, so we'll stop over here. Okay, one last point. So machine, how it makes our work easy? It makes our work easy by multiplying force, acting as a force multiplier, or multiplying speed, or by changing the direction of it. All right, thank you so much. Bye.